Our first topic we cover in Algebra 1 is a review and expansion of solving equations and inequalities. This is a really small topic because it's supposed to be a review, but it is absolutely critical to everything that you do in high school math. So I'm going to make a series of videos that are going through different stages of solving equations, some of which are review, some of which are new. I encourage you to watch whatever ones you feel like you need. So this first one, we're going to talk about the most basic idea of solving equations, which some people don't really get because they haven't really internalized it. So we're going to start off with the idea of our order of operations. And this is a little bit skinny. So our order of operations, which we call PEMDAS a lot of times as an acronym, stands for the order in which we do different operations when we are evaluating an expression. So if I had something like 4 plus 3 times 2 plus 7 minus 8, then this tells me what order to simplify these things. So I follow parentheses first, so I'm going to simplify anything inside of parentheses and turn this 2 and 7 into a 9. So we add that together. Then I look for any exponents. In this case, there's no powers, so there's no exponents, nothing is being squared or cubed, so we ignore that one. Then we look at multiplying and dividing. They have the same priority, so we go left to right anywhere we see those. The only place we see a multiply or divide is right here. 3 times 9 is what these parentheses mean. So it says 3 parentheses 9. That's the same as 4 plus 3 times 9 minus 8. So this multiplication is more important than the adding and subtracting around it. So we're going to simplify that into a 27. Finally, addition and subtraction also have the same priority, so we follow left to right and do any adding and subtracting. So first I'm going to do 4 plus 27 is 31, and then I'm going to do 31 minus 8 is 23. So this order of operations is for simplifying or evaluating an expression in which we know all the values. On the other hand, when we're solving equations, we actually follow this exactly backwards. So instead of PEMDAS, we get SADMEP. And it's the same grouping, so like adding and subtracting have the same priority, multiplying and dividing have the same priority. And we're going to go through some examples of how these different operations show up and the order in which they need to be done. So a really simple equation with just one variable on one side would be something like x plus 7 equals 4. In this problem, the only operation that's happening is I'm adding 7. So when I add 7, I need to do the opposite of that thing. So when we're basically unraveling or solving an equation, so solve means to isolate the variable, which means to get it by itself. So right now I have x plus 7. There's an addition happening that's keeping the x from being by itself. So these operations come in pairs. Adding and subtracting are opposite operations, and dividing and multiplying are opposite operations or inverse operations. So we isolate the variable using inverse operations. So in this case, to get rid of that addition, we need to subtract. So we're going to do minus 7 to both sides. Whenever we do something to an equation, if we do it on one side, we have to do it on the other side as well. So any of these operations need to occur on both sides. And if you think about it like a scale or like a balance, I have two things here that are equal, and they are basically have equal weight pulling down so that this is in balance. If I add some, so I say I have a couple things on each side. If I add something to one side, then it's going to be heavier. I need to add it to both sides to keep it in balance. So anything that I subtract or add on one side of the equal sign, I have to do the same on the other side. So now I have 7 minus 7. That creates what we call a zero pair. 7 minus 7 is 0. So now there's only x on the left. And on the right side, I have 4 minus 7. So now there's negative 3 there. Since the x is by itself, this is now solved, and we say that that's our solution. X was negative 3. And if I go back to my original equation and plug in that value, so where I had x plus 7 equals 4, if I plug in or substitute negative 3 here, I get negative 3 plus 7 is equal to 4. Now, if I use my normal order of operations to evaluate this, I add these together. Negative 3 plus 7 is 4, and 4 equals 4. So that's a true statement, meaning we got the right solution. So that's an example of addition and how we undo addition. We also can do the same with subtraction. If I have x minus 3 equals 8, and then I look at this operation, my x has a subtract operation added to it. So to get it by itself, I'm going to need to undo subtraction, and I do that by addition, because adding and subtracting are inverse operations. Then I'm left with x is equal to 8 plus 3 is 11. So undoing subtraction and addition are pretty much exactly the same, just in reverse. Next, we're going to look at multiplication. So if I have 3x is equal to 9, then this is a little different because there's nothing added or subtracted from x. Instead, we've multiplied something by x. And looking at our order of operations, PEMDAS, we know that the opposite of multiplying is dividing. So in order to fix this, we have 3 times x. Remember that a variable and a constant written side by side, we call this one a coefficient, and it tells us how many of the variable there are, and there's a hidden multiplication operation in between them. So to undo that multiplication, I'm going to divide both sides by 3. When I divide the left side by 3, I have 3 divided by 3, which is 1x. Also remember that when we write x, that's always a single x. There's a hidden 1 in front of it that we don't write. So as long as we have a single 1 of that variable, we just call it its name. We don't put a 1 in front of it. And then that's going to be equal to 3 on the other side. Dividing is the same kind of thing. We can write division. We usually write it as a fraction rather than as like a division symbol. So you'll notice here I put over 3 instead of like divide by 3. We don't usually write it that way. So a division problem would be something like x over 3 is equal to 2. So in this problem, I identify that I have x divided by 3, and I know that to undo division, I need multiplication. So my path forward here is to multiply both sides by 3. So I usually write multiplication as parentheses. I could also write it as like a dot. The one thing we don't want to do is write it as an x, because then we get it confused with a variable if x is our variable. So just like the previous problem, we have 3 divided by 3 is 1. So I'm left with just a single x. That was my goal. And on the right, I have 2 times 3, which is equal to 6. So that's my answer. Then lastly, exponents are a little bit tricky. I'm going to mention them here. So if I have like x squared is equal to 4, then the opposite operation of square, you probably know, is square root. So if you think about 2 squared is equal to 4, and the square root of 4 is equal to 2. So those two operations are opposites, and they undo each other. We'll learn later in the year that it's not quite that simple. For now, we're just going to say if we have x squared, then let me grab this color. So this is an exponent. So to undo that exponent, I'm going to square root both sides. When I do that, the square root of x squared is just x, and the square root of 4 is 2. So in this case, x is equal to 2. You don't need to worry about it yet, but technically the answer is both 2 and negative 2. because if you think about what number you can multiply by itself, which is what squaring is, to get 4, 2 times 2 is equal to 4. But negative 2 times negative 2 is also equal to 4. So we'll revisit this more in quadratics. For now, we just need to know x is equal to 2. And in the second semester, we'll worry more about the fact that there's 2 solutions, but there is a second one that's kind of less obvious at this point. All right, finally, let's look at one example putting these things together. We'll leave exponents out for this one. So we'll do 2/3 x plus 7 is equal to 13. So for this last problem, we have multiple operations, and this is where the ordering of PEMDAS backwards is important. So remember, we have P, E, M, D, A, S, and we're following it in backwards order for solving equations. So I'm going to identify my operations. I have an addition, and here I have a multiplication and a division. So of those 3 things that have happened, if I'm going in reverse order, addition is the first thing that I need to deal with. So I kind of got in my own way here. Let me just erase. We have PEMDAS written in multiple places. Okay, so my first thing that I need to deal with is this addition, and I deal with that by subtracting 7 on both sides, and then I rewrite what's left over. So I didn't change this 2/3 x, it's still there, and then I have equal to 6. Now this 2/3, there's 2 ways of thinking of it. First of all, I want us to understand that 2/3 x and 2x over 3 are the same thing. We call these equivalent expressions. They both mean we're multiplying x by 2 and dividing it by 3. So we can undo this in 2 different ways. The most basic way would be to consider the multiplying and dividing separately. So to do that, I'm going to look first at my division, and I'm going to undo that by multiplying by 3. So I'm going to do times 3 and times 3 to get rid of the division, and 3 divided by 3 cancels, so I'm left with just 2x is equal to 18. Finally now, all I have left is a multiplication operation. I have 2 times x, so I divide by 2. And when I do that, I get my final answer of x equals 9. So that's putting all the things together. Let me go back to this step and talk about the other way of thinking of it. So we had 2/3 x equals 6. Instead of thinking of multiplying and dividing separately, we can think of 2/3 as being a single thing that's being multiplied by x. It's being multiplied by a fraction. So to undo a multiply by a fraction, we multiply by what's called its reciprocal. So I could multiply both sides by 3/2, and that's going to cancel out as well. So notice here, I did really the same thing. I multiplied by 3 to cancel the 3, and I divided by 2 to cancel the 2. So I'm left with x equals, then I have 3/2 of 6, which is 6 times 3, that's 18, divided by 2 is 9. So I get the same answer whether I think of multiplying by a reciprocal or multiplying and dividing separately. It really does the same thing, so it's not important which one you do. That's part of the beauty of algebra, is we do things in different order. As long as we do valid things, we come up with the right answer. As a close to this video, I want to go and talk about why we follow this order going backwards. I'll use this same problem again. So we have 2/3 x plus 7 is equal to 13. So I said we need to deal with the addition first, but I want to talk more about why that is. So if I try to deal with multiplying or dividing first, so my step 2 here was to multiply by 3. If I multiply by 3 first, then the problem is there's multiple terms on the left side. So each of the pieces here, the 2/3 x and the 7, both have to be multiplied by 3. The reason for that is in our hierarchy in PEMDAS, multiplying is more powerful than adding and subtracting. So multiplication can apply over things that are added and subtracted. That's why when we solve, our goal should be to get rid of adding and subtracting first, then get rid of multiplying and dividing, then exponents. So we're going backwards through that list. If we don't go backwards through the list, we can still get a valid answer. So if I multiply by 3 here, 3 times 2/3 x is 2x, 3 times 7 is 21, and 3 times 13 is 39. Then I would subtract 21 and get 2x is equal to 18, and divide by 2 to get x is equal to 9. So I can get to the same answer. The problem is students forget a lot of the time that when you multiply by something and there's still an addition, the multiplication applies to it as well. So the error they make here is they'll put 2x plus 7 equals 39, forgetting to multiply this 7 by the 3 that we multiplied everything by. So really common mistake, and following PEMDAS backwards will keep you from making that mistake.